All right. So 1.2, exploring absolute value. Um, this is how we show absolute value function, right? F of x equals, and this is the signs that we use. So on the number line, this function describes the distance of any number x from the origin. It always results in positive version of the number. So if you have an absolute value of 4, so that is same as 4, okay? And that describes the distance between 0 and 4. So that is 4 units. Therefore, absolute value of 4 is 4. So if you have absolute value of -3, so the result is going to be +3, because that describes the distance between -3 on the number line and 0. And if you look at it as a distance, it will give you +3 units. Okay. So let's look at example 1. So we are going to evaluate -1 minus absolute value of -2. So -1 minus absolute value of -2 is +2. So you cannot just multiply. Don't think it as a bracket, and do not multiply this negative sign by that negative sign. Okay, so first calculate absolute value of -2, put it there, and then do the calculation. So we get -3. Let's look at example B. Okay, so negative. So absolute value of 3 minus 8. So 3 minus 8 is -5. Minus absolute value of -2 is +2 times absolute value of -5 is +5. Okay, so again, don't multiply this negative sign by that negative sign. Absolute value of -5 is +5. So we have 2 times 5 here, 10. So -10. So we get -50. Okay, example 2. Consider the absolute value inequality. Okay, so you have absolute value of x greater than or equal to 3. So we are going to graph this on a number line. 0, 1, 2, 3. All 5 and goes negative sign, -1, -2, -3 and goes. Okay, so we want absolute value of x greater than 3. So yes, you should take all the numbers that are greater than 3, +3. That is one part of it. Okay, but also look, if this x, let's say -4, what do you get? Absolute value of -4 gives you 4, so which is greater than 3. Or if you have absolute value of -5, that is 5. Again, it is greater than or equal to 3. Okay, so means you're going to take all those numbers that are less than -3. So now you have to decide about exactly -3 and 3. If this was only greater than 3, then you would put holes here. But it says greater than or equal to means -3 and +3 are included. Okay, so that's how we graph it on the number line. And it says express the solution set using inequality notation. So this part, if you look at it, x greater than or equal to 3. About the part on the left, so those are x less than or equal to -3. Okay, so if we want to write absolute value of x greater than or equal to 3, if we want to write it without the absolute value sign, then we can write it as x less than or equal to -3 and x greater than or equal to 3. Okay, so then this would be the solution, or writing it without the absolute value of sign. Absolute value sign. Okay, so let's look at this one. Example 3. Given the graph, describe the solution set with absolute value notation and inequality notation. So as we see here, x is between -3 and 3. So let's write it with inequality notation, without absolute value. Then we would say x is between -3 and 3. So x greater than -3, less than 3. If you want to write this with absolute value, then we can say absolute value of x less than 3. Okay, why we don't use less than or equal to? Because as you see, these points, -3 and +3, are not included in the solution set. Okay, so we see holes here. So that is the reason it's just less than. So when you compare these two graphs, okay, if you have absolute value of x greater than or equal to 3, then you have these pieces here as a solution. And if you have absolute value of x less than 3, then you have the solution between -3 and +3. Okay, having said that, now let's write the same thing here. First with inequality notation, and then with absolute value. So we see now x must be greater than 2, also less than -2. So x greater than 2 and x less than -2. Okay, so that is inequality notation. Now we're going to write it with absolute value. So I should use absolute value of x then. And looks like the other one is going to be 2 number. Okay, so now you should decide if you should put you should put less than or greater than sign. Okay, so we are looking at the size like just like this one. So x must be greater than 2. And you can always check if it works, right? So take one solution from here. Let's say 3. Sub in. Is this good? Yes, right? Absolute value of 3 is 3, which is greater than 2. Or take a value that is less than -2. Let's say you take -4. Sub in. Absolute value of -4 is 4, which is greater than 2. Okay. Now it says, given the inequality, create the absolute value expression. So x is greater than or equal to -5/8 and less than or equal to 5/8. Okay, so looks like this example 3a. So x is between two values. Okay, so then absolute value of x, and one side is going to be 5/8. So decide if you should put less than or greater than. So looks like it's going to be less than, right? Again, you can try. Pick a value from here, from this interval. So let's say you take 1, right? No, 1 doesn't work. So let's say 0.5. 0.5. Take it, put it here. So absolute value of 0.5 is less than 5/8. So it works. You can always check your answer by taking a sample value. So B, given the inequality, create the absolute value expression. So x less than -2.5 or x greater than 2.5. So looks like, you know, this example is just like 3b. Okay. So then we're going to have absolute value of x. And this time, again, you need to decide if you should put greater than or less than. Okay. And that's going to be greater than again, you can always check your answer picking a value. Let's say we pick a value that is less than negative 2.5, negative 4. Sabin, absolute value of negative 4 is 4, which is greater than 2.5. So basically, if x is between two values, then you get the absolute value of x less than a certain number. And if you have two different intervals, okay, just like 3b, just like 4b, okay, then you get absolute value of x greater than that certain value.
For 4a, do we put the greater or less than and equal to, or just less than?
Based on the question, oh, this one for a, yes, there is going to be equal sign. Thank you for reminding. You can pick up any sample value. Yes, I fixed less than or equal to 5/8. Aber, I think the problem is with yours on your side because everyone else hears. I don't think he hears. All right, so let's go and look at the next page. So this time we are going to solve absolute value equations or inequalities. So we have some steps to follow. Okay, so step 1, isolate the absolute value expression. Step 2, rewrite the equation without absolute value, considering both positive and negative cases. Solve each equation and finally check your answers. Okay, so even though if the question doesn't ask you check your answers, you have to do it anyway. All right, so that is actually part of the question, because when you're solving absolute value equations, sometimes you get an x value that doesn't work. Okay, therefore you have to do official check, proper official left side and right side check for this kind of questions. Okay, so let's apply these. So we start with something simple. Absolute value of x minus 5 equals 0. So first, isolate the absolute value expression. So we move negative 5 to right. So 3 plus 5 gives you 8. Step 2, rewrite the equation without absolute value, considering both positive and negative cases. So then either x is positive 8 or negative x is positive 8. Okay, then you get x equals 8 already here, and then if you isolate x from here, you get negative 8. So you have two solutions. So if you check it, positive absolute value of positive 8 minus 5 gives you 3. So left side is 3 and right side is already 3. If x is negative 8, sub in, absolute value of negative 8 is 8 minus 5 is 3, and right side is also 3. So left side equals right side. So both solutions are good. How about if you have this absolute value of x less than 8? Okay, so in this case, this question is just like the previous page. Okay, so if you had, let's say this, right? If you have x less than absolute value of x less than or equal to 5/8, then if you write it without the absolute value notation, then we said that it is x is greater than or equal to negative 5/8 and less than or equal to 5/8. So then, you can just apply that knowledge here and then say x is between negative 8 and 8. That's it. Okay. Again, you can always take a sample value. So take x value that is between -8 and 8. Let's say you take -1. So then absolute value of -1 is +1, which is less than 8. So it works. Okay, x greater than or equal to 8. This was less than. Now it is greater than or equal to. Okay, and this question is just like this, right? When absolute value of x is greater than 2.5, if you write it without the absolute value notation, then you get x less than -2.5 or x greater than +2.5. So this time we are just going opposite way. Okay. Then x is less than -8 or x is greater than 8, but it says greater than or equal to. So we should also have greater than or equal to or less than or equal to. Again, if you want to check your solution here, pick a value, x value that is less than -8, -9. So in here, absolute value of -9 is +9, which is greater than 8. Or pick a value here, let's say 10, absolute value of 10 is 10 greater than 8. Okay, D. Again, we are applying the steps. Isolate the absolute value of absolute value expression. So with these two, absolute value expression was already isolated, so we didn't do much in that case. But here we have to isolate absolute value expression. Okay, so then we need to get rid of this 2 and we need to get rid of that -4. Okay, so let's move -4 to the right. 24 plus 4, which is 28. Now let's get rid of 2. Think this 3x minus 1 is a single variable. Let's say just think it as an x or something, and then isolate it that way. Okay, so the same steps are applied. Now we need to divide both sides by 2. 3x minus 1 equals 14. Now we finished the first step. We isolated the absolute value expression. Next, rewrite the equation without absolute value, considering both positive and negative cases. So then we are going to say we will have two solutions. So we have to write it without the absolute value notation. So either 3x minus 1 equals 14, that is the positive case, or negative 3x minus 1 equals 14. So make sure you use bracket. You could also do it this way, which is fine. You could also say positive 1 is 3x minus 1 equals 14. And the other one is 3x minus 1 equals negative 14, and so on. Okay, so whichever you find easier to do. So, but one of them is positive case, so you take whatever you see inside the absolute value as it is, and keep the right side. And for the negative case, if you are using this one, okay, so you take whatever you see inside the absolute value and you multiply it by a negative sign. Then you solve, okay? Isolate x from here. So -1, move it to the other side, you get 15. Divide both sides by 3, you get x equals 5. So now this one, so distribute that negative sign. Negative 3x plus 1 equals 14. Negative 3x, move 1 to right, so you get 13. and x equals negative 13 over 3. Now we have to check. Okay, so we are going to do now official check. So for x equals 5. So left side. When you are doing the check, you always have to use the original equation. Okay, that is important because some students use, let's say, this equation or these ones here, so it doesn't work. You have to use the original equation when checking. And using the equal sign, separated, divided as left side and right side. So left side we have so we have 2 times absolute value of 3x minus 1 minus 4. And we have right side, which is 24. So now we substitute 5 for x. 3 times 5, 15. Okay, so absolute value of 14, which is 14. So 28 minus 4 gives you 24. And right side is also 24. So left side equals right side. So let's check x equals negative 13 over 3. Left side is 2 times absolute value of 3x minus 1 minus 4. And right side is 24. Okay, so 2 times absolute value of 3 times negative 13 over 3 minus 1 minus 4. Okay, so we multiply this, 3 and 3 is gone, negative 13 minus 1, so negative 14. So absolute value of negative 14 is positive 14. So 28 minus 4 gives you 24. So left side equals right side. That means these two solutions are good. Both of them are good. Okay. Again, when you are doing this for evaluation, even the question will not ask you to check it. You have to check it, okay? And show this work. And make sure you separate left side from right side. Do not do this, okay? Please. So this is the original equation. And then you are, let's say, checking 5. Don't do this, please, okay? 24, and then you do this 2, 14 minus 4, and then you get 24 equals 24. Okay, we don't do this. No. All right. So let's look at E. First step, isolate the absolute value expression. It is already isolated. Then now step 2, rewrite the equation without absolute value, considering both positive and negative cases. Okay, so we will have 2. Okay, so case 1 here. So we take the positive case. So whatever you see inside, take it as it is. 2x plus 5. And case 2. Okay, so take the what you see inside the absolute value expression and multiply it by a negative sign. Make sure you use brackets as you do that. Okay, now we are going to solve two equations again. So collect x is on one side. So I'm going to move 2x to the right, 4 to the left. So we get x equals 1. Okay, so let's look at case 2. So distribute that negative sign. Negative 2x minus 5 equals 3x plus 4. Then collect variables on one side and numbers on the other side. So we get negative 9 equals 5x, x equals negative 9 over 5. So now we check. So let's check case 1. Case 1 check. Left side, again, I go to the original question. The left side is absolute value of 2x plus 5. And right side is 3x plus 4. So let's do it for case 1. So x equals 1. So you get 2 times 1 plus 5, 7. The left side is 7. Right side, 3 times 1 is 3. So you get 7. Left side equals right side. X equals 1 is a good solution. So let's do the check for case 2. So left side is absolute value of 2x plus 5. Right side is 3x plus 4. Okay, so 2 times negative 9 over 5 plus 5. Negative 18 over 5 plus 5. Have a common denominator. 5 times 5, 25. So negative 18 plus 25 is 7. So absolute value of 7 over 5, which is 7 over 5. Okay, so right side, 3 times negative 9 over 5 plus 4. Negative 27 over 5 plus 4. So have a common denominator. 5 times 4 is 20. So negative 27 plus 20 is negative 7 over 5. As you see, left side and right side are not the same. The left side is not equal to right side. So this solution is not good. Okay. And again, please, when you're solving this for the evaluation, maybe half of the marks are going to be for solving it, and half of it is going to be for checking the answer. So make sure you do that, okay? So if we have absolute value of x equals negative 3. Okay, so absolute value of any number. So can it ever be a negative number? What we said, whatever you have inside the absolute value, at the end, you either get 0 or a positive number. So absolute value of any number can never be a negative number. So this one is no solution. G, absolute value of x greater than or equal to negative 3. Again, when you take the absolute value of any number, you always get 0 or 0 or any positive number. And 0 or any positive number is, they are always greater than -3. So whatever you have for x is going to work, because if you put it in the absolute value, you will always get 0 or positive number. So then the answer for this is going to be x, any real number.